Okay, folks, here we go. Ready to start engine disassembly. I've got our Toro LC 154F engine here on the table. I've got my disassembly packet for the Toro engine. And off to the side here and beyond the camera view, I've got a variety of tools, plus a sheet of cardboard for organizing my fasteners as I take them out of the engine. Okay? We're going to go through the disassembly packet step by step. I'll talk about each of the steps and kind of what needs to be done and try to offer some tips and tricks as we get through it. Make sure to get your checkpoints as you get to your checkpoints when you're having your lab times. And don't forget to ask questions if you have any. Okay? First thing we're going to do when we start out is we are going to locate our engine manufacturer and engine information. Oftentimes, as we're servicing engines, we need to be able to look up service info, and that can be different from different engines, so we need to know specifically what engine we're working on. I already told you this is a Toro, and then the next thing we need are some engine numbers. And we will find these on our engine on this barcoded label attached near the bottom of our crankcase. What we're going to be writing down is this first set of numbers in the upper left corner. Okay, and it should be 10908077-4. That's what we want to write down. Okay, that's Toro's model numbering system for these engines. Okay, so once we take out a pen, we're going to take out a pen, we're going to write this down. Make sure you answer all the questions that are asked in the packet so that I know that you at least tried to answer them. Sometimes the answer might be none, or you're not sure what to put down. That's where you come and ask me a question. So the next thing is are there any parts that appear to be damaged? Okay, so we're going to take a look at our engine. We'll spin it around. This might be the first time you're looking at this engine that closely, so I'm not expecting super long or detailed answers. You might not even know that you're missing or have any damaged parts, and that's okay. This engine is in pretty good shape. I don't see anything damaged, so I'm going to go ahead and write none. And then the next question is, are there any signs of oil or other fluids leaking from the engine? Don't see any up on the bottom there, so I'm going to also say no or none. Okay. Next thing we do is we need to disconnect the spark plug wire. Anytime we work on our service on an engine, it's a good idea to disconnect the spark plug wire, especially if it's a service that doesn't need the engine to be operable. Oftentimes, like changing a lawnmower blade or taking the lawnmower blade off to sharpen and balance. Since it's attached directly to the engine, and sometimes you need to spin the blade around to get it positioned properly, if the spark plug wire was left connected, that could lead to a serious safety issue. So it's always a good idea to disconnect the spark plug wire so the engine can't start. On this particular engine, you'll find our spark plug wires right here. It's this heavy gauge wire that goes right over the top of the valve cover for the cylinder head. We'll get into more of the parts ID as we take apart the engine, so bear with me on that. It goes into a metal protective boot here, okay? And whenever we disconnect the spark plug wire, we don't want to yank on the wire. We want to grab the boot and we want to twist and pull on the boot. Some come off fairly easy, others will come off a little bit more difficult. But we're going to go ahead and disconnect this and just let it hang for right now while we do our thing. Okay, that's step one. Step two, we want to check and make sure that our gas tank is empty so that there's no gas spilling out when we go to disconnect it. This one's nice and empty. If the person that worked on the engine before you didn't empty the gas, or they didn't empty the carburetor bowl, okay, there might still be some gas in it that we'll want to drain out so that it's not leaking in our locker, creating a fire hazard, or spilling all over our workplace, maybe soaking our packet, requiring us to, start over with a fresh packet. So we'll check that. If you don't have any, great. If you do and you're not sure what to do as far as get it out, call me over and I can help you with that. But I will touch on some of the points about draining gas a little bit later in this video. Up next, may be helpful to have a rag handy, but right down here near the bottom of the crankcase is my dipstick tube. I want to grab that and unscrew it. Sometimes they can get a little bit stuck. Okay. And basically what I'm looking for is to see if there's any oil on the dipstick. Let me turn this around so you guys can kind of see it better. Here's my dipstick. And you can see it looks like there's a little bit of dab of oil on the end of the dipstick. I'm going to take my blue shop towel here and I'm going to wipe that off. And so now you can see the dipstick looks relatively dry. See the checkered area here? As long as the oil levels in this checkered area, it's okay by the manufacturer. But since we're getting set to take these engines apart, we'd rather not have any oil in it. So I'm going to thread this back in, and hopefully maybe that was just a little bit left on the end of the dipstick from the last time it was drained. And then I'll thread it back out. And it's still clean and dry all the way to the end. So I've got probably most of the oil out that I can get out. You never quite get 100% of the oil out just by draining it from the dipstick tube hole here. In order to get all the oil out, you pretty much have to disassemble the engine and wipe all the oil out. So be advised that there will still be a little bit that can potentially leak in the future. But for right now, we can put that back in and we can move on to step 4, which is checking for spark. This is more of a diagnostic test to help you guys with learning how to troubleshoot an engine that maybe doesn't start. Because just because an engine doesn't start or doesn't run well doesn't necessarily mean that it needs a full rebuild. And so we're just gonna, why would we be servicing an engine? And just to show you some diagnostic tests. So I've got 2 different style spark testers here. This is the spark plug style. It's got a large gap to it and the spark is exposed. This style has a light bulb in it that will light up, and this plugs in line with the spark plug wire of the engine. We're going to use this style because this style doesn't really fit or work very well with the metal boots on this engine. Like it doesn't go in far enough to make a proper connection on the tip of the spark plug tester. Okay. So you'll notice this bulb style right here. This tip looks a lot like the tip of a spark plug. That's going to plug into here until we hear a distinct click. Now it's kind of quiet, but it did click. And then this part is a boot, and that's going to clip right on top of the spark plug underneath the muffler here. And hopefully you heard the click on that one. Next thing we need to do is make sure our stop switch, which is this red key, is pushed in all the way. That will allow the engine to start. If it's pulled out, either one click or all the way out, it won't allow the engine to start. And what there is there's a switch behind here that shuts down spark production by the magneto. So if we don't have this in, it'll fail the spark test every time. Now what we want to do is, with the bulb in view, we want to pull the engine over and check and see if it flashes while we pull the engine over. So I'm going to try to hold this there, and I'm going to give a good pull on the pull cord, and hopefully you saw it flash. Let me just hold it up at a different angle here. Okay, it did flash, and it was relatively bright for these bulb style testers. So on my packet, I'm going to circle yes, it did flash, and then bright because it was bright. If for some reason you can't check for spark, there's a spot that you can put that down. Then come over to me, ask me to help you figure out the reason if you're not really sure, and we'll sign off and we'll move forward. After the spark test, there's a checkpoint. Make sure you get that checked before moving on to the next phase. When disconnecting the spark tester, it's a lot like your spark plug wire here. You want to hold it by the boot, twist and pull. Same thing down here. Twist and pull on the boot until it pops off. There's only a few of these in the shop, so we need to share these with others, so make sure you put it back right away rather than leave it sit by your work area where maybe other people don't know it is. So we'll put that off to the side. The next diagnostic test that we're going to do is called a dry compression test. For that, we need to remove the spark plug. And to remove the spark plug, I'm going to use a 3/8 drive ratchet, a 3/8 extension, and a 13/16 spark plug socket that can be found in cabinet number 3. Okay, it's a special spark plug socket that has a rubber insert to protect the ceramic of the spark plug. And I got my ratchet in the off or counterclockwise position. Position this over the top of the spark plug. And they might be a little bit stiff to remove, and it might want to move the whole engine when you push on it. So a little trick is to put it into a position that's easy to get at. Take the meaty part of your palm here and just give the ratchet hand a little bump or two. And that's usually enough to break it free, hopefully without breaking the spark plug. And then we can spin it out. I do want to mention to you guys that I'm using all hand tools for the video here because this is mostly what you have available to you, as well as this is likely what you might have at home. I realize that not everybody may have electric impacts and everything else. If you have those at home and want to use them at home, great. But here in class, part of what we're doing is practicing the use of our hand tools. So that's going to be the use of the hand tools is going to be emphasized. Anyways, here's my spark plug. It's now stuck in my spark plug socket. So I got to get a good grip on the threads here, and I got to pull and wiggle it on my socket. They can sometimes be a bit of a bear, but they'll come out. Just make sure you got a good grip on it so they don't go flying, because the ceramic can and does crack if you drop it from the height of the workbench or if it rolls off the side. So make sure you put it someplace safe where it's not going to roll off to the side. I'm going to set mine underneath the camera there. Set the tools off to the side. Now I have a hole directly into the combustion chamber of the engine, and I can take my compression gauge and I'm going to thread this right into the spark plug hole of the engine, and we're going to measure how much compression the engine is able to generate. So I got to kind of straighten out the holes a little bit. I got to line up the threads in the hole and hold them straight while I spin it into the hole. And then it should snug up after a couple of turns, and hand tight is all I need. There's no tools needed for this. This is a gauge. It's relatively sensitive to shock and vibration, so we will want to avoid it flinging around while we're trying to install it or use it for testing. I usually like to curl the hose up and then hold the gauge in the engine with my hand and arm while I pull on the cord with the other. When doing this compression test, I want to make sure that I pull on the cord 3 to 4 times. I'm looking for 3 to 4 compression strokes of the engine on the needle. Okay? And then hopefully my gauge should hold the pressure. Some of my gauges are getting a little bit old and worn out, so if one's not working right, bring it to me, let me know, so that I can either replace it or rebuild it and get it working properly once again. Okay? And I want to pull it like I'm trying to start it. There is a choke lever also on the carburetor. I want to make sure that's pointing towards the primer bulb here, so that way the choke is wide open. So I'm going to give it 3 good pulls while I use my hand and arm to hold the engine in the gauge. And this one, as you can see, bleeds down a little bit, but I did achieve about 40 psi of compression. This gauge, after the video is made, is going to get new valves in it because of this, but I'm going to go ahead and record 40 for the purposes of moving on. As far as what should we be looking for compression, this engine has compression release, and we will talk about that more in class when we talk about engine operation. But we're looking for at least 35 psi on a compression release engine to consider the cylinder and the compression system relatively good. Okay, usually new engines are much more. And so the follow-up question is, okay, I put down 40 psi for my dry test, and is the cylinder good? Based on what I just told you, I'm going to say yes, it's good. It meets our minimum 35. Could it be better? Yeah, probably. But part of why it's lower is going to depend on how this engine was last assembled, most likely. And so maybe we'll see something as we get into it a little bit deeper. If I had pressure trapped in here, press this little black button to release it. Then I can straighten my hose, unthread it, and like these spark testers, I've only got a few of these for the shop, so we want to put it back in cabinet 3 so that other people can find it and do their test. All right, after you get that done, it's time for another instructor checkpoint, and it's step 7. Make sure you get those signed off and don't blow past them, because as we get into future checkpoints, it's going to be hard for me to know whether you did things correctly or not after you've taken parts off the engine. So make sure you're getting those when you get to them. You might have to be proactive and seek me out instead of waiting for me to come by and notice you're ready for a checkpoint. Okay, so I've gone ahead and put together a cardboard with most of the fasteners and items from your engine that I would normally put on a piece of cardboard. Wanted to just show you what this is going to look like when you're done with it. You're seeing this earlier in the process, but by the time you get done with it, this is pretty much what your cardboard should look like. And this, having a cardboard set up this way will make your reassembly process go so much easier versus just taking the bolts off and throwing them in your locker and letting them lay in the bottom, okay? And especially the labeling part too. You can stick them in there, but if you don't label them, they all look the same from the top, and that's not very helpful. So make sure you take the time to label them. This is one of the reasons why it's important to always bring a writing utensil to class with you. But you can see here we got fuel tank bolts, heat shield bolt. I believe in the video I left mine in, but I went and pulled it back out to put together a cardboard for you. We got the 4 shroud bolts, the 4 bolts for your valve cover, the starter motor which came off before the valve cover. The bolts are in the block. We got a crankcase cover, and we got our magneto bolts there. Got rocker arm bolts. These ones are very position sensitive. The top one is a long one, the bottom one is a short one, and then the left and right ones have the small flanges. And then down here we've got our governor linkage and spring. We got our push rods labeled intake and exhaust, top and bottom. Got our flywheel key and our flywheel nut. You're definitely, obviously you have space for a lot more. You can put your tappets on here. You can put your valves and springs on here if you'd like. Try not to tape them up too badly because you'll need to unpack them halfway through for the inspection phase of things. Usually I just try to set some, since the valves and stuff are kind of bigger, or like the lifters or tappets, those you can sometimes wrap up in a blue rag, set them in the back of your locker where they won't be disturbed. But your cardboard should look pretty similar if you're organizing things and following recommendations, and this will help your reassembly process go much more smoothly. Here we have cabinet 3. This is where we'll find our specialty tools. It's in the corner of the shop by the valve grinder and the ultrasonic cleaner. Okay, this is what it looks like on the outside. There's 3. It's got the wood grain door. It's labeled specialty tools. We'll open it up here. In here is a variety of tools we need for engine building. Some we need for reassembly, some are disassembly, some are for both, some are for diagnosis and troubleshooting. You can see here we've got our compression gauges and feeler gauges. Down here we've got spark plug sockets. Notice that the 3/4 is actually mislabeled or mixed up. This is my 3/4 here. Somebody had that in the wrong spot. Over here is my 13/16. These are the ones that get used for our spark plugs. This is where our spark testers go. These are the 2 spark plug style. And then this is where the bulb styles go. The feeler gauge hangs right up on that peg like that for the steel ones. And the brass ones are over here on the right door, and they go here. There's 2 in each of the holes, so there should be 6 total there. Okay, and then the compression gauges set up on the hooks there. These ones are a little bit old and worn out, but the gauge itself should rest there, and then the hose is supposed to clip into there, but you can see my clip is a little bit loose, so I'll have to, that loosens up over time, so I'll have to go and do that. But do try to get them put back in a proper way so that they can be stored properly and found when needed. And then up in the upper left here, you can see the 2 rolls of masking tape. That's the tape for you to use to tape down your engine components to your cardboard, such as your governor, spring, and lever, or your push rods, and what have you. Okay, so that's cabinet 3. A super short, sweet tour. We'll talk more about the other tools when we get to them.